Welcome back, everyone. Today, we're diving into a genuinely brilliant Mark Tech Post tutorial by Sana Hassan. We're going to break down step-by-step how to build an end-to-end accounts payable extraction pipeline. We'll be using this incredibly powerful tool called Lift PDF to take messy, totally unpredictable documents and turn them into perfectly structured data. If you've ever had to deal with the absolute headache of manual data entry, well, you're going to want to pay attention, because this pipeline is a real game changer.
Okay, let's dive into this. Have you ever stopped to think about the sheer volume of manual data entry happening in finance departments literally right now? Or the absolute nightmare of trying to maintain those brittle, rules-based parsers that just completely break every single time a vendor decides to change their logo size? Yeah, we've all been there. It's a massive pain point in finance automation. So we really have to ask ourselves a fundamental question here. What if invoices could just parse themselves?
To get there, here's our roadmap for today's explainer. We'll start by moving beyond traditional OCR, look at schema-guided document intelligence, prepare some synthetic data, run the Lift pipeline, and finally, validate and build our ledgers.
Section 1. Beyond traditional OCR.
So there's a really stark contrast between these two approaches. Traditional OCR, well, it's a bit like trying to read a document completely blindfolded. It just pulls raw text, left to right, top to bottom, and it totally ignores the visual context. You build a hard-coded rule to find the subtotal, right? And then the very next day, the vendor moves that subtotal line just 2 inches to the right, and boom, your entire parser breaks. Schema-guided intelligence, on the other hand, is like giving an AI a highly specific, strict checklist. It actually uses a vision model, meaning it's layout-aware. It visually knows what a table looks like, or what a total line looks like, regardless of where it sits on the page. And the best part? It outputs beautiful, highly structured JSON.
Moving right along to Section 2, Schema-guided document intelligence.
Let's lock in a clear definition for what this actually is. Schema-guided document understanding means we are generating structured JSON by extracting values directly from rendered PDF layouts based on a target schema. Basically, instead of writing endless lines of code just to find a PO number, we simply tell the model, hey, I need the vendor identity, the PO number, and the tax amount. That's it. The model looks at the visual layout of the page and just plucks those specific fields right out for us. It's a massive fundamental shift from writing extraction rules to writing data schemas. And let me tell you, that makes maintaining these pipelines infinitely easier.
And what exactly is the engine driving this extraction? 9 billion parameters. Let that sink in for a second. That is the size of Lift PDF vision model we're exploring today. This isn't just some lightweight basic text parser. No way. This is a heavy-duty, visually aware AI with some serious horsepower under the hood, specifically trained from the ground up to understand document layouts.
And this brilliantly illustrates why that parameter count actually matters in practice. Check out these performance metrics from Data Lab's benchmark. Lift PDF boasts a 90.2% field accuracy, which noticeably outperforms Azure's 83.4%. But honestly, the real kicker here is the speed. Lift PDF has a median latency of just 9.5 seconds. Compare that to a massive 73.7 seconds for Azure. When you're processing thousands of invoices at the end of the month, that difference in speed scales up into some truly massive cost and time savings. It's highly accurate, and it's incredibly fast.
Section 3. Preparing the synthetic data.
Sana Hassan's tutorial provides us with a really clean setup here. First off, we pin a stable version of Pillow in our Google Colab environment. If you've ever dealt with dependency hell between Pillow, Torsion Vision, and Transformers, well, you know exactly why this compatibility fix is absolutely crucial for a smooth run. Next, we defined our raw invoice fields and compute the derived values to make sure everything is mathematically sound. Finally, we actually render these synthetic invoices into realistic PDFs using a library called ReportLab, and preview them with PyPDFIM2 and Matplotlib, so we are literally generating the exact visual pixels that Lift will read and process.
Now, we aren't just making easy, clean invoices here to make the model look good. We are intentionally setting up some specific extraction traps. We want to really stress test the model's resilience against real-world finance chaos. So we throw in separate build-to and ship-to addresses just to see if it gets confused by proximity. We force it to clearly distinguish between a subtotal and an after-tax total. We intentionally leave some fields completely blank to ensure it returns a clean null instead of just hallucinating data to fill the void. And we even test its logic by having it mark partially paid invoices as unpaid if there is any balance remaining.
Section 4. Running the lift pipeline.
Okay, let's talk about the code mechanics, because they are beautifully optimized in this pipeline. We start with GPU-aware model loading, and we apply 4-bit NF4 quantization. Since we're dealing with that massive 9 billion parameter model we talked about, this step is absolutely vital to save VRAM. Otherwise, it simply wouldn't run on a standard GPU without running out of memory. But the single most important step for scale here is initializing the inference manager. We do this exactly once. By reusing this manager, we entirely avoid the massive overhead of repeatedly loading that huge model into memory for every single invoice in a batch. Once the model is nice and warm, we just execute our helper function wrapping lift.extract.
So the crucial point is captured perfectly in this one simple phrase, schema in, valid JSON out. The JSON schema we define acts as a foolproof map. It gives that massive 9B model highly explicit instructions, guiding it safely through all those sneaky extraction traps we just set up, like the build to versus ship to trick. It guarantees that the data we get back is formatted exactly the way our downstream database is expected to be.
And finally, Section 5, validating and building ledgers. We have to prove the model actually worked, right? So the tutorial implements some rigorous scoring functions. We take lift's predicted JSON and grade it field by field against our known synthetic ground truth. But it's smart grading. It has a built-in tolerance for numeric formatting differences, so it seamlessly handles variations like commas versus decimals. It can accurately process deeply nested vendor objects and really complex arrays of individual line items. Basically, it verifies that the AI didn't just grab random text on the page, but actually understood the math. Because in finance, close enough just doesn't cut it. This rigorous validation is exactly what makes the pipeline production ready.
And here is the grand finale. We take all of those validated JSON records and convert the whole shebang into a compact, queryable Pandas data frame. We end up with one row per mined invoice. As a data engineer or a finance analyst, you can instantly query this table for outstanding invoices, sort it by vendor, or calculate the total unpaid balances across the entire batch. We've completely bypassed those messy visual PDFs, outputting a clean, mathematically sound, fully automated ledger that is ready for instant analysis.
We've covered some truly incredible ground today. We went from bypassing brittle OCR to generating synthetic stress tests, and finally building a perfectly parsed ledger using Lift PDF. I want to leave you with this final, provocative thought. If a single schema and a vision model can untangle the notorious complexities of accounts payable invoices, what other stubbornly complex documents in your organization are just waiting to be decoded? Think about it. Purchase orders, dense medical records, or even legal contracts. The tools are absolutely here. The schema is yours to define. Thank you so much for joining me on this explainer today. Keep learning, keep building, and I'll catch you next time.